you to this live session of GATE HT questions, the PYQs, right? So I hope that all of your preparation is going very well, and you are doing good. Only hardly 3 months is left for the examination, and your preparation should be really at the peak. So what I mean is that you must be under a lot of stress. You must be working your way out every day, learning new concepts, trying to accommodate all the things together. And to help you out, every now and then we are coming up with the live sessions where we are not teaching any concept as such, but we are discussing the good PYQs that have been, that have come up. And solving PYQs is a very important thing when it comes to, for the preparation. It is one of the most fundamental part. Now everyone is recommended to go through the PYQs at least once, solve every question, see how questions are coming. Questions will not be repeated, that is true, but concepts, most of the concepts gets repeated, and the concepts gets repeated, and solving a PYQ will give you a very good idea that what can you expect in the question. Obviously some changes will be there. So my dear friends, good evening. Yes. Okay. So without wasting any time, my dear friends, today I have with me HT questions that have come up in GATE 2022. Yes. So 2022, a total of 4 HT questions, that is heat transfer questions, came, and those were really very good questions. One of the best, if you ask me, then I would say that one of the best in the last 3-4 years, the questions that have come, and today we are going to take up those questions itself. So mechanical students who are preparing for their GATE, they can obviously refer to this video. Most of the concepts would get clear. So my dear friends, let's check the first question that have come. Let's check the first question. Consider a rod of uniform thermal conductivity whose one end x equal to 0 is insulated and the other end is exposed to the flow of air at temperature T infinite with convective heat transfer coefficient as H. The cylindrical surface of the rod is insulated so that the heat transfer is strictly along the axis of the rod. The rate of internal heat generation per unit volume inside the rod is given by Q dot equal to cos 2 pi x by L. The steady state temperature at the mid location of the rod is given as TA. What will be the temperature at the same location if the convective heat transfer coefficient increases to 2H? Option A, TA plus QL by 2H. Option B, 2TA. Option C, TA. And option D, TA into 1 minus QL by 4 pi H plus QL by 4 pi H T infinite. So it's a very good question, and if you see the the pattern of the last 4-5 years, heat generation is one of the most important topic from where questions have regularly come. So it's giving you a hint that yes, we should prepare this topic in a very good way. Now my dear friends, you know that for steady state d2t by dx square plus q dot by h is equal to 0. This equation I am going to consider, right? This is the equation. So d2t by dx square is equal to minus q dot by h, and now we will integrate. So before that, d of dt by dx and minus q dot by h into dx. Now when you integrate, till now what you have been doing is that q dot you are taking out. Why? Because there was uniform heat generation. That is why you are allowed to take out q dot out of the integration sign. For example, if I just put an integration over here, you can take out q dot just because earlier it was uniform. But see the question, my dear friends, it is a case of non-uniform heat generation. Why? Because q dot is varying with x. It is non-uniform. At every location the q dot is changing. So I cannot take q dot out and simply later on put the value. Something like that you cannot. Also one more thing, earlier in whatever, when you are taking q dot out, so earlier the conditions were such that H was already always present in your temperature profile equation. The heat transfer coefficient was always present in the temperature equation. So some of you will think that why to solve that H is present and linear, it is present as a linear power, so directly proportional if we just assume, so something kind of 2 TA answer we should give. But remember, that was for different set of boundary conditions. The boundary conditions clearly here will be different, and it's a case of non-uniform heat generation. So whenever some changes takes place, you should always go to the basics and start your equation from there. So I hope you got the point. So d of dt by dx is equal to, now here I will be writing minus 1 by h, and in place of q dot it is cos 2 pi x by L into dx. So if you integrate, it will be dt by dx is equal to minus 1 by h. Now cos x integration is sin x, so sin 2 pi x by L, into L by 2 pi. If I again, by substitution, L by 2 pi will again come. Don't say that it is the chain rule doesn't apply in integration, okay. And plus a constant C1, plus a constant C1, plus a constant C1. So dt by dx is equal to minus 1 by h into L by 2 pi into sin 2 pi x by L plus C1. Now here we can use a boundary condition. He has given that this is the cylinder. Now the left end is insulated. So at x equal to 0 it is insulated. This is the x equal to L, and temperature at the midpoint is given as TA. Okay. So this is insulated. So when the left hand is insulated, so try to understand, all the heat generation is left hand, no heat is going. All the heat is flowing from left to right. So always heat flows from higher temperature to lower temperature. So from basic sense, can we say that the left hand most one will be the maximum temperature? Yes or no? Because heat is flowing from left to right, so higher to lower. So leftmost heat is starting to flow from leftmost point, so temperature at the leftmost point will be maximum. And if something is maximum, the slope is 0. So one thing I can say, that the dt by dx at x equal to 0, the dt by dx will be 0. So at x equal to 0, so substituting 0, at x equal to 0 if you substitute, so sin 0 will be 0 plus C1, which gives me C1 equal to 0. So again if I write dt by dx is 1 by h into L by 2 pi into sine of 2 pi x by L. Now C1 is 0. Again we have to get the temperature profile. So d of T will be minus 1 by h L by 2 pi into dx. So if I integrate again, so this will come as T is equal to minus 1 by h into L by 2 pi into, now sine 2 pi x is minus cos 2 pi x by L, and L by 2 pi again it will come, so whole square, and minus will make it plus a constant C2, okay. So now again we have to use the boundary condition. So what boundary condition we can use? Temperature we don't know, so we can use that at x equal to L, heat conducted is equal to heat convected. So for heat conduction, you know that I am going to use the Fourier's law, minus k dt by dx at x equal to L, and heat convected is h T temperature at x equal to L minus the T infinite. So minus k, and when I substitute dt by dx at x equal to L, so this is the dt by dx equation. When I substitute x equal to L, so minus 1 by h into L by 2 pi into sine 2 pi, and when L I put, L and L gets cancelled. So sine 2 pi, sine 0, that means 0. So entire term gets cancelled, is equal to h T x equal to L minus T infinite. So left hand side becomes 0, and h, if you bring it down, again that will also become 0. So what I can conclude, that T at x equal to L is equal to T infinite. T at x equal to L is equal to T infinite. T at x equal to L is equal to T infinite, right? Yes. So what will be the C2 value? So T at x equal to L, if I try to find out, so I'll substitute x equal to L over there. So L and L will get cancelled, L and L will get cancelled. This is T infinite is equal to, L and L will get cancelled, cos 2 pi will be 1. So 1 by h L by 2 pi whole square plus C2 plus C2 plus C2. T infinite is equal to, yes. So C2 we can get from here, T infinite minus 1 by h L by 2 pi and whole square. So C2 value we can get from here. Now see, what is your temperature profile? This is your temperature profile. Now let's say I substitute C2 value over here. I substitute C2 value over here. So in this temperature profile, this is not containing any H term. This is not containing any H term. Already in the original term there was no H term. So what I can say that in the temperature profile there is no H term present. In the temperature profile there are no H terms present. So we can say that the temperature is independent of the heat transfer coefficient. It is independent of the heat transfer coefficient, and even if you vary from H to 2H, the temperature at any the section is not going to be affected, right. So earlier if the temperature at the mid location was TA, so even if you increase to 2H, it is going to remain as TA only, right. So this is the thing, in your temperature profile, there are no H terms, because this C2 when I substitute over here, no H term is present. Earlier also no H term is present. So in your temperature no H is present. That means it is independent of the heat transfer coefficient, right. So I hope you got the solution. The answer will be option C, that is TA, right. Okay. So what did we learn from here? We learned that how the equations are getting derived, that is also very important, because if you didn't know that, then you would have probably not be able to solve this question. Okay. Moving ahead, read this question once. Okay. Consider a one-dimensional steady state heat conduction process through a solid slab of thickness 0.1 meter. The higher temperature side A has a surface temperature of 80 degrees centigrade, and the heat transfer rate per unit area to low temperature side B is 4.5 kilowatt per meter square. The thermal conductivity of the slab is 15 watt per meter Kelvin. The rate of entropy generation per unit area during the heat transfer process is how much? During the heat transfer process is how much? Okay. So there is a slab given. The left end is at a temperature of 80 degrees centigrade. 80 degrees centigrade. The right hand temperature we don't know, that is at B we don't know. The heat transfer is steady state heat transfer is 4.5 kilowatt, so 4500 watt per meter square. The thermal conductivity is 15 watt per meter Kelvin, and the thickness is 0.1 meter. The thickness is 0.1 meter. So what is the entropy generation? So first of all, you know that we have to get the temperature of B. So Q is equal to K TA minus TB by L. So Q is what? 4500. K is what? 15. Now 80 degree minus TB by L. L is 0.1. So when you take 0.1 over there, it will become 450 by 15 and is equal to 80 minus TB. So this will become 30. So TB will become 50 degrees centigrade. So 80 degrees centigrade, that means in terms of Kelvin it will be 273, 80, 353 Kelvin and this is nothing but 323 Kelvin. 323 Kelvin. Okay. Now my dear friends, here we have to apply the entropy balance equation. Here we have to apply the entropy balance equation. Entropy balance equation. So the entropy balance equation is entropy which is entering minus entropy which is exiting plus entropy which is getting generated within the system is nothing but the change in entropy of the system. Change in entropy of the system. And per rate, if I, that means if I divide everywhere by time, so it will become SI dot minus SE dot plus S generation dot, and this will become d of entropy change of the system ds, or simply I can say ds by dt. Simply I can say ds by dt of the system. Now my dear friends, first of all, this equation, that is the entropy balance, is applicable for any system, any process, right? It is, this entire thing is applicable for open closed system and any process, right? So this is the entropy balance equation, and it is similar to your energy balance equation. Energy balance also we write in the same way, that energy it is entering, energy that is leaving, energy that is generated of the control volume is equal to the rate of energy of the change of energy of the system. Yes, this is also similar to that. Now remember one more thing, that if it is the steady state system, if it is a steady system, for example diffuser, nozzle, turbine, compressor, if it is a steady system, so the change in energy of the system will be 0. That is why energy inlet equal to energy outlet we do and get the steady SFEE equation we give. So here also we should see that whether the system is steady or not, or somewhere steady have been mentioned. So clearly we see that it is mentioned steady state conduction process. Since it is given steady state, so this thing will become 0. For steady state it will become 0, and therefore S generation dot equal to S of E minus S of I. Now what is S of E? That means entropy at the outer wall. What is the entropy? So you know that entropy I will be writing by Q by T. So Q by TB, Q by TB, Q by TB minus Q by, at the inlet it is TA. So Q value is 4500, that is watt per meter, watt per meter square, 4500 watt per meter square, and TB we just now we have to put temperature in Kelvin. 1 by TB, TB is 323 minus 1 by 353. So this will become 4500, 353 minus 323 divided by 323 into 353. Now already it is, already the unit of 4500 is watt per meter square. Already it is watt per meter square, and Kelvin by Kelvin square will make it Kelvin. So so whatever we get, that will become the answer. Whatever we get, that will become the answer. So 353 minus 323 . So 1.18 we are getting, 1.18 watt per meter square Kelvin. 1.18 we are getting. So the answer is 1.18. entropy balance is similar to energy balance, and this is how we have to solve this question. Moving to the next question. Okay. Consider a solid slab, thermal conductivity K is equal to 10 with thickness 0.2 meter and of infinite extent in the other two directions as shown in the figure. Surface 2 at 300 Kelvin is exposed to a fluid flow at a free stream temperature of 293 Kelvin with a convective heat transfer coefficient of 100 watt per meter square per Kelvin. Surface 2 is opaque, diffuse and grey with an emissivity of 0.5 and exchanges heat by radiation with very large surrounding at 0 Kelvin. Radiative heat transfer inside the solid slab is neglected. The Stephen-Boltzmann constant is given. The temperature T1 of the surface 1 of the slab under steady state conditions is what? So, steady state conditions is given, heat transfer is occurring by conduction, and in the slab it is occurring through conduction, and after that convection and radiation. So, we can apply the steady state conditions and we can simply write the equation, heat transfer by conduction is equal to heat transfer by convection plus heat transfer by radiation. So, if I write heat transfer by conduction, it is Ka. Now, T1 minus T2 by L is equal to, by convection it is HA T2 minus T infinite plus sigma A epsilon T2 to the power 4 minus T T surrounding to the power 4. So, A gets cancelled from everywhere. So, K value is 10, T1 value it is asking to find out, T2 value is 300 and L value is 0.2 meter. H value is 100, T2 value is 300, yes, minus 293 Kelvin plus sigma value is 5.67 into 10 to the power minus 8 into epsilon 0.5 and T2 is 300 to the power 4 and T surrounding is 0. So, my dear friends, if you solve this equation, if you solve this, you are going to get T1 as, you will be getting T1 as 318.6, 318.6 Kelvin, 318.6 Kelvin, right? Yes. So, I hope you got this question. Nearest integer, so we have to write 319. Nearest integer, so we have to give 319 Kelvin. Okay. And let us get to the last question. During open heart surgery, a patient's blood is cooled down to 25 degrees centigrade from 37 using a concentric tube counterflow heat exchanger. Water enters the heat exchanger at 4 degrees centigrade and leaves at 18 degrees centigrade. Blood flow rate during the surgery is 5 liter per minute. Now, some properties have been given for blood and water, and he is asking what is the effectiveness of the heat exchanger. So, if I so let us say hot fluid, that is the blood, is flowing in this direction and the cold fluid, which is water, is flowing in this direction. This is TH inlet, TH exit, TC inlet and TC exit. So it is given that patient's blood is cooled down from 37 to 25. So this is 37, this is 25, and for water it is 4 to 18. It is 4 to 18 degrees centigrade. So all the temperatures have been given, and finally he is asking you the effectiveness. So what is effectiveness? Effectiveness is actual heat transfer by maximum heat transfer. Actual heat transfer by maximum heat transfer. So actual heat transfer I will write after some time. Maximum heat transfer is TH of inlet minus TC of exit, that is the maximum temperature difference, and here we write the heat capacity of the low, which is the low heat capacity. Now we have to determine whose heat capacity is the lowest. Now if I write the energy balance, that heat lost by blood is equal to heat gained by water. So C of the blood into, now what is the temperature difference? 37 minus 25 is equal to C of the water, which is 18 minus 4. So C of the blood into 12 is equal to C of the water into 14. So what we can say, that when 14 is higher than 12, so definitely C of water will be less than C of blood. C of water will be less than C of the blood. Yes or no? So C of water I will write, and here I will write what the temperature difference of TC exit minus TC inlet. So C low and C water gets cancelled. So T or C of exit is 18 minus inlet is 4 by 37 minus, no, here I should write TCI. Maximum we are taking now, so TCI minus 4, right? So it will become 14 by 33. So what will be 14 by 33? 0.424. 0.424 we are getting. 0.424 we are getting. So this is the effectiveness. 0.424 is the answer, right? So my dear friends, this is it. 4 questions came in HT 2022, and very good questions came. So I hope that at any stage, even if you want to revise or if you want to refer to the solution from understanding point of view, you can refer this video and share it with your friends who are also preparing for the exam 2025, right? So for any doubts, you can just comment in the chat box and I'll be replying it. Now GATE 2025-26, if you want, you can join it. For 26, if you want to start your preparation early, you can join it. It will be 800 plus hours of live classes with the interaction, theory book, exercise book. 34 years of GATE question bank, you will be getting that too, with the video solutions, and alternative solutions have also been provided. 12 personalized one-to-one mentorship sessions have been given for you along with the test series, right? My dear friend, test series plus, where you will be getting test, the question booklet GQB plus the test series. So you can consider it purchasing, and I will be saying you what is the difference between plus and test series. In test series plus you will be getting the PYQs also, that too two booklets. One we will be getting for your core subject and another for your the mathematics and aptitude. Along with that, test series doubt solving portal, online revision, post gate guidance, and all these things, that too for a price of 3299. And finally, you can consider joining the Telegram, where you will be getting daily quizzes, updates. And my dear friends, let me tell you that these days updates from major companies are coming almost every 2-day, 3-day basis. You might miss some of the information, so do join it. Will be giving you a very fast update of all the examinations, right? So thank you very much. We'll be coming up with many more such live sessions. Stay tuned and keep up your hard work, right? Take care. God bless.